picking up where we left off last time with equations. So we're going to do a variety of examples. We gave some basic examples last time, and as you push forward in your homework, you've seen probably some variations on that. And so we're going to look at a variety of other variations that you're going to see. Same basic rules we already went over. But some things as far as like cleaning them up before you're ready to solve them, that can get a little confusing. So we'll look at some, like I said, some variations on that. So solving radical equations. And so not to rewrite this was from the notes last time, and it's been posted as well. So don't need to write this down, it should be in your notes from last time. Like I said, it's posted. The basic idea, no matter how much more complex we get today, the rule is the same. We cannot solve radical equations, just like we couldn't solve rational equations in the last unit. Okay? What we had to do is transform them. We transformed the rational with the LCD over 1, killing the denominator. We transformed rational equations into a nice flat polynomial, either linear or quadratic polynomial equation. Okay? Same thing we're doing with radical equations. We can't solve the radical equation. We're going to transform it into a polynomial equation, okay? Either linear or quadratic, and then solve that. Okay? So with rational equations last unit, we transformed those by killing the denominators, multiplying every term by the LCD over 1. To transform a radical equation, we use the power rule, which we raise both sides to the same power, and that power should be the same as the index, because a power cancels out an index, a square cancels out a square root, a cube cancels out a cube root, and so forth. And if you raise both sides to the same power, that power rule says you're keeping it fair, you're keeping that scale balanced. So that's a good rule that will transform it, it'll kill the radicals. A matching index and exponent, inverse operations, blows up the radical. So you get rid of the radical and you're left with a linear or quadratic equation, okay? Which you solve accordingly. Linear, you solve for x. Quadratic, you put it in standard form, factor into 2 linear factors, and get your 2 solutions. Okay? And the only thing about the power rule, it's a legal mathematical move. However, it's important to realize that it may produce extraneous solutions. Okay? So the solutions to the original radical equation are going to be among the solutions to the new equation. Okay? So that means that you'll get all the possible solutions by doing this rule, but there's some you may need to throw out. You have to check, not just because, oh, I have enough time, I want to check my work to see maybe I didn't make a careless mistake. No, you have to check your proposed solutions back in the original equation to make sure they're good, not just for the polynomial, but for the original radical. And if the answer is no, then you throw those solutions out. Now, our basic setup, our list of steps, whether it's a simple or more complex radical equation, is always the same. You must isolate the radical first. You cannot make other decisions until you do. Okay. So it's isolated. You want the radical all alone on one side, and just a number or the number in variables, anything free-floating, on the other side. It doesn't matter what side the radical's on. Just make sure it's alone on that side. In fact, we're going to look at a couple of examples where if you're trying to isolate the radical, and if it's negative, if there's a negative sign or subtraction sign in front of the radical, you want to move it to the other side just to make it positive. Okay? Just like wanting to keep a quadratic positive because it's easier to factor. Okay? So once it's isolated, you power up both sides, parentheses around both sides, powered up by whatever the index is. You get a linear or quadratic, you solve that, and then you check for extraneous. So the same basic set of rules, no matter how complex these get. So our basic ones, we're going to square roots. This is already isolated. Square both sides. We're left with a linear. Solve for x. Check 1 back in the original. It makes it true, so this proposed solution is a good solution. Put it in that set notation and walk away. Here we got more going on under the radicand. Still, squaring that square root releases the radicand, as long as you're fair to the other side. And then you've got a simple linear that you solve and check to make sure it's not extraneous, and it was good. Now, if you have a square root equal to a negative number, that's a problem. Because a square root always gives you, unless you're told otherwise, is going to give you a positive. The principal square root is a positive square root. So if you see a square root equal to a negative number, and you're not going to know if this is the case until you isolate. You can't make this decision until it's isolated. Because sometimes it'll look negative, but then when you isolate it, it'll become positive, or vice versa. This one's already isolated, so you know a square root is not going to result in a negative answer, so it's no solution. Now, if you had gone through and worked this out, you can square both sides. You get 3x equals positive 36, because negative 6 squared is positive 36. Divide both sides by 3, and you get x equals 12. But when you plug it back in, 12, 3 times 12 is 36. Square root of 36 is positive 6. And then you see, oh, so that's an extraneous solution. Throw it out, so there's no solution. So you can ignore that and do the work, but why do all that extra work if you don't have to? Okay? If you can see right away, oh, that doesn't make sense, that's impossible, so I can stop right there. Okay? Well, I wouldn't count it wrong if you worked it out, as long as you saw, oh, it's extraneous and threw it out. I'm likely, depending on the mood I am when I grade, to give an extra point for recognizing that right off the bat. Because I want you to be more efficient that way and recognize those rules. So that effort will be rewarded. And of course, isolating first in this case. Got to move that over first. If there's a coefficient, you don't have to divide it away. We'll see a couple examples now where you may divide it away, you may not. If it's a negative, definitely divide it away, if you couldn't avoid the negative in the first place. But otherwise, a coefficient, we'll see how you handle that one way or the other. But definitely anything that's added or subtracted must be moved over. Then square both sides. When it's released, you have a linear, solve the linear, check that it's not extraneous, it was good, so you move on. So in all of these first examples, our right-hand side was a number, just a plain old number. Okay? No second radicals, no x's, and no free-floating x's. Okay? Just a number on the right. Okay? So some of the variations we're going to look at now have other elements to them that make it a little more complex when you square both sides, but it still follows the same rules. Okay. Oh, and I just wanted to, because I forgot to point this out from the beginning, about the practice test. Just to point out that a couple of directions we're speaking of, like giving extra points for or giving full credit versus not. Make sure you read the directions carefully on the practice exam. For example, number 6 at the second page. I actually just put a note, not really an extra direction. But you can expect a lot more of these, including ones with coefficients other than 1s. Okay? Like some of the examples we did in class. So just, the practice test hints that this is important. But I just want to point out on the test, just like in our notes, what we do in class and the notes and examples we do are also important when you study. And so being able to distinguish between the product rule and and adding two radicals, like radicals, and the product rule, whether you have coefficients of 1 or other coefficients, how you handle that is really important. So whether this is just, square root of 7 times square root of 7 or 2 square root of 7 times 3 square root of 7. How would you handle the coefficients there? How would you handle the coefficients if it's 2 square root of 7 plus 3 square root of 7? Okay? What would those coefficients look like? So refer to your notes and examples in class. I don't want you to be surprised when you get the test. And it's things like this, understanding these two rules, but maybe there's going to be some more of them, that also have other coefficients and variations on that. So you want to be really comfortable with the difference between these rules and what it means to multiply versus add, and how you handle the coefficients in response. Okay? Down here with the multiply, starting with number 9, I encourage you to write everything in expanded form, whether you're distributing, foiling, binomial squared, or conjugates. Write that expanded form step, because with radicals it gets really messy and easy to lose track if you don't. But specifically, as I said out loud and warned you before, use that formula, that pattern, to expand and simplify conjugates and binomial squared specifically if you want to get full credit. So if you recognize conjugates, I want you to expand it as a squared minus b squared. If you recognize a binomial squared, you should expand it as a squared plus or minus 2ab plus b squared. And then simplify. Yes?
For the ones that you were saying, like the square root of 7 times 7, like higher up, is that simplified? Do you want it like even further? Like let's say it was any other number, like let's say 9 or no, let me think, like 8. And then you know how you find the factor?
Oh, right, like you partially simplify? Yeah. Like square root of 8 would be 2 times the square root of 2?
Yeah.
Right, yes. Anytime you combine them according to the plus or the minus, then the final answer should be totally simplified.
Okay.
Yeah. Now, for our purpose, for this, when I want you to illustrate these, and like, for example, on the test, I'm giving you a big hint here, there's going to be ones like this, but several more, that include variations of plus and minus and coefficients. I'm not going to make those so that then you have to do a lot more simplification. You're going to show me you can do that in other problems.
Yeah.
So this problem with more of these, with more coefficients, is basically going to be, can you understand the difference between whether this is plus or whether it's multiplication? Yeah. Yes, you should always simplify in the end if you can, but I'm going to keep that, you're going to show me that really in a different problem.
Okay.
Yeah. So yeah, watch out for that. So if you see that binomial squared or that conjugate, make sure you expand it according to that formula, the pattern. Okay, not foiling it out. If you just foil it out, you'll get some credit if you get it right, but not if there was a formula you could use instead. That would be the full credit. Okay. So then we get to the equations, which we're going to practice some more right now, and then finally, starting on page 5, will be 11.2. You can see we're working with exponents that are fractions instead of integers. Okay, sorry, I meant to do that. Before we got started, let's get right back into this. So some other variations on equations we can solve. Okay, so just to get warmed up with what we've done, and that idea of those steps, and then we'll expand on that. So these will go pretty quickly. I want you to be really efficient with these. This is where we left off. Say, example, square root of 3x plus 3 minus 14 equals negative 2. Square root of 5x minus 2 plus 3 equals 1. And cube root of 2x plus 6 plus 4 equals 0. Okay. So remember, of course, you must isolate first before you can make any other decisions. Okay. Once the radical is isolated, you power up both sides. Unless you notice, hey, now that it's isolated, that's just going to be nothing. Did this give you pause, this negative 2?
Say it again?
Well, this is a square root, right? So is this negative 2 okay?
Yeah.
Yeah. We're not going to make a decision about that yet. Because if we're not isolated, once we isolate, that negative might go away. Or it might have looked fine and been a positive, but when we isolate, it makes it negative. So until you're isolated, yeah, don't even worry about that. Now, radical alone equal to a number, it's a square root or an even root, positive, good to go. Once both sides were powered, you're left with a basic linear equation, minus 3 on both sides, 5 both sides by 3, solving for x. Now, you can plug that back in by pencil and paper, mentally, or on your calculator. I'll show the calculator skill one more time just to emphasize that. Because this is just equal to a number, you don't have to use the test button. You could just enter this, push equal, and if it equals negative 2, you're good. I just use the test button across the board just to be consistent, because a lot of times on the right-hand side is not a simple number. There's other stuff. So you'd enter the left-hand side, push equal, and the right-hand side, push equal, and see if they balance the same thing. And then a lot of people get that number confused with what the actual solution is. I prefer to keep it just clean and consistent and use my test button. So I enter my proposed solution is 47. So 47 stored in x, enter. And then I go all the way back to my original equation. Okay? Because yes, this is the right answer for this linear equation. We want to know if it's the right answer for the original. So the radical, 3x plus 3. Now, if you've got math script, you've got a blinking cursor, you would arrow out. In this case, with parentheses, you've got to close the parenthesis. Otherwise, when I write minus 14, it's going to think it's under the radical sign. So you have to close the parenthesis, just tell the calculator I'm done with the radical sign. And now, minus 14. And I use my equal sign to test. That's under the math key, test. So it's second math test. Lots of things you can choose. We're just using equal sign right now. We'll get to inequalities later in the semester. So we'll just push enter to get an equal sign. And make sure when you enter that negative 2, using the negative sign, which is under the 3 on your keypad, not the subtraction sign, or you'll get an error, negative 2. Now, when I push enter, I'm going to get a 1 or a 0. That doesn't mean 1 or 0 is my solution. That means true or false. So enter, and it tells me true. That is a good solution. If I plugged in 47, it satisfies this equation. It keeps it balanced. So 47 in set notation, and I can walk away. So ready to power both sides? Nope. That's a problem. It's isolate. That wasn't a problem before. Once you isolate, square root, nope. If you solve it out and then check, you'll be able to solve it, just plug it back in, you'll get extraneous. So you can just go straight there if you recognize that. Let me be real clear, that's not a coefficient of 3, that's a cube root. Whatever the root is, it still needs to be isolated first. Oh, is that a problem now?
No.
No. Why not?
Because it's cube.
Right. Cube roots, any odd root allows, bless you, negative radicands to happen, and it allows negative solutions. Okay. Now we want to cancel out the cube root with the cube. We're always using the exponent that will create that inverse operation. So those will cancel out. Be careful, put everything in parentheses. This is negative 4 cubed. Bless you. It won't make an effect with an odd exponent, but in general, your base, the side is a parenthesis because that can change what the base is, which can change signs. So 2x plus 6 is equal to negative 64. And now simple linear. Now let me point out that no matter what the index is, whether it's an even index or an odd index, it doesn't matter what the index is, it is absolutely possible for your answer to be positive or negative. Okay? And x being positive or negative is not a problem. Because when you plug it back in, even if this were a negative answer, well, there's other stuff going on. There's things added or subtracted to it, multiplied to it. Just because x is negative doesn't mean the radicand's going to be negative. Okay? So no problem with the negative x as long as it's a good solution. Okay? Because x got other things going on that can change it from positive to negative. A negative x isn't a problem. A negative radicand is the problem. Or a negative answer is a problem if it's a square root. So in this case, it wouldn't be a problem anyway, but if it were a square instead of a cube, don't think, oh, I have to throw that out because it's negative. No. X can be positive or negative. It's just up here, a radical cannot be, or square root cannot be equal to a negative. But this is fine. I'm going to check that back in there, either mentally or on paper on my calculator, and I find it's a good solution. Moving forward, I'm just going to tell you if they're good solutions or not. You do need to check them, though. Okay, don't skip that step. You need to check it. Questions about those basics? Now, so far, what we've looked at before and sort of warmed up with here is that on the right-hand side, we end up with just a number. Not always the case. As you would have encountered moving forward in homework, problems like this. So radical 4 minus x is equal to x minus 2. So here, our radical is isolated, but over here we've got not just a number, but also a variable, free-floating variable. Now, is that negative 2 there a problem?
No.
No, because if there's an x, I mean, we don't know what x is going to be. So x could be something that keeps this positive. So if there's a variable over here, it doesn't matter whether the other numbers are positive or negative, because a variable can change everything. Now, certainly our x is going to end up having to be 2 or more. Because if it's 2, this will be 0. If it's greater than 2, then it'll be a positive number. If x is less than 2, then that would make this negative, and that would be a problem. We can already sort of get a hint of what a bad solution would be. Anything less than 2. When you start noticing those things and paying attention. We can check it. If you don't notice, it's fine. You're going to check your work at the end. But the more you sort of think about those things, oh, this has to be a positive answer, so x better be 2 or greater. Okay. Now, it's isolated, so square both sides. And both sides, the entire thing, goes into parentheses. Now here is the biggest mistake that I see on the test. And the reason, and me seeing this consistently on the test that we're about to have on Thursday, is the reason that I have spent so much time up to this point emphasizing binomial squared. Okay? So I'm going to point it out again. I want you to notice this. Because otherwise, lots of people make this mistake. Notice if you're going to, I want you to point it out, I want you to notice it, I want you to pay attention in homework if you're doing this. X minus 2 squared is not equal to x squared minus 4 or x squared plus 4. Okay?
You have to FOIL it.
Well, I'd rather you not FOIL it though. If it's a binomial squared, I want you to use the pattern. Now you can certainly go, okay, this is not conjugates. X squared minus 4 would be x plus 2 times x minus 2. And there's no way to get x squared plus 4, so that's just not anything. But the point is, people who do this are saying there's no middle term. There is a middle term. A binomial squared has a middle term. Conjugates, the middle term cancels out. You get a difference of squares. Binomial squared, you have a middle term. Now, if there are radicals involved in this, yes, I want you to expand it out and, into the formula. If you go off to the side and expand it with FOIL, you're going to get to the right answer. But I am, again, just like nag. This, I want you at this point to be able to do this mentally. I want you to handle these with ease and efficiency. We're going to be doing this again in another context in the next unit. It's not going away. So when I say handle ones like this, if there were a radical in it, I'd expand it out. We'll see an example like that in a minute. But just plain old numbers, I want you to see binomial squared, that makes a perfect squared trinomial, there's a middle term, and I'll be able to think that pattern. A squared, AB doubled, B squared. Okay? Mentally foiling. So this, of course, becomes 4 minus x. It's released. And this equals my first term squared, a squared, and this will tell us whether it's minus or plus, minus. And then a times b doubled. 2ab just means multiply these together and double it. So 2x doubled, 4x. And then always plus on the last one because a binomial squared is 2 pluses or 2 minuses, so plus 4. Don't avoid trying to get into that flow, that efficiency, that mental habit with these binomial squared. Okay? Understand that will give you a middle term. Okay? And especially without any radicals or huge numbers, you should be able to do that mentally at this point. Now, I see I have a quadratic. Okay? So the radical's dead. I'm ready to solve my polynomial, and it's a quadratic polynomial, so I'll get 2 solutions. And I'll get them by putting it in standard form, factoring it into 2 linear factors. So my x squared is positive where it is, so leave it there. If you try and move everything to the left, it's going to make a negative x squared, and then you're going to have to factor out a negative 1. Okay. So if you're putting things in standard form, if your leading term, your quadratic, is already positive, leave it where it is and move everything else over to be with it. Okay. So I'm going to move the 4 over and the x over. So, that actually just cancels out the 4, and I've got a plus x. Okay. So those cancel out to 0. I'll just cancel out entirely. So I'm left with 0 on the left is equal to x squared minus 3x. Now, just because your brain probably likes it better, we can just flip it over. A equal B is the same thing as B equal A. I'm not going to change or move over the equal sign or anything, change anything, just x squared minus 3x equals 0. But I moved everything to the right because my quadratic was already positive, and I didn't want to move it over here and make it negative, because then it just gets awkward. There's another step of factoring out that negative 1. Now, this is quadratic, binomial or trinomial? Binomial, right. So if this were a trinomial, you do your ACB method. Find your ACB, your magic pair of numbers. But this is not a trinomial, so don't immediately go to ACB. What's the first thing you always ask yourself when you factor? Yeah, and because these are both terms with x's, it does have a GCF of at least an x, if not a number. No number in this case. But pull out an x, and you're left with x minus 3. Okay. See? No ACB. ACB method is when you have an A, B, and C, which is a trinomial. Okay. Binomial with a GCF. Now you've got your 2 linear factors. Either x is equal to 0, or x minus 3 is equal to 0, so x equals 3. These are your 2 proposed solutions. We already sort of established, even if you don't remember, you're still going to check it back in the calculator, but remember, x has to be 2 or bigger. So when you check that 0 back in here, you're going to end up with square root of 4 on the left, which is 2, but over here 0 minus 2 is going to be negative 2. It doesn't balance. Okay. So checking it mentally, on paper, in the calculator, you'll see that x equals 0 is an extraneous solution. It is a correct solution to this polynomial, but not to the original equation. And when you check 3 back in the original, you'll see 3 is good. So you got your 2 polynomial solutions, but only one of them is a good solution for the radical.
So anytime it equals 0, then we just.
No, sometimes 0 is a good answer. Yeah. Don't throw it out just because it's 0. It just wasn't a good answer for this problem. Yeah. You got 2 good answers to this quadratic polynomial. Both of them might be good. Neither of them might be good. Or in this case, one of them was good. Yeah. But you got to check every problem on its own merits.
So by checking it, check 0, you have to, you can see if it's good or.
Right. Yeah, you could plug it in here. Okay? Like I said, you can plug it in mentally. 4 minus 0 is 4. Square root of 4 is 2. And on this side, it would be 0 minus 2, which is negative 2. It doesn't balance. Or you store 0 in x, and then you enter this whole thing using your test button and get a true or a false. Remember, it'll come back false as 0. That doesn't mean 0 is a good answer. That means when you use the test button, 0 means false. That makes sense, the difference? Yeah. So if you put store 0, enter this, test, and get a 0, that doesn't mean, yay, 0 is an answer. No, it means 0, false. 0 is not an answer. Okay? 1 and 0, true and false when you use the test button. Okay, so a variation of this is more about, so when you can see these variations in homework and maybe on the test, as I said, the rules themselves are still the basic rules done in the order that we listed. But some of the cleanup might get a little confusing or chaotic, and you have to be really careful to clean it up in a way that is efficient and maintains what sign, don't make careless mistake with signs, etc. Okay? So we have a single radical in this one, but we also have a free-floating x and a free-floating number. We need to get this radical all by itself, and then we can apply the power rule. But notice how this radical is negative. Just like what we did here, where this, x squared was already positive, so we left it there instead of moving it over. We want to keep the x squared positive when we're putting in standard form. Same thing here. If we're isolating that radical, we want it to be positive. Otherwise, we'll have to deal with, dividing away negative numbers. So let's move this over to the right. That'll make it positive, which means we're going to move this 4 over to the left. Okay. So basically, you're going to be adding square root of x plus 16 to both sides.
Or couldn't you just take the x minus 1 and just move it over to the...
There's no x minus 1?
Wouldn't it be, 1... No, yeah, you're right. Never mind. That's not right.
Okay. So by moving this over to the right, I cancel out. So this leaves just an x here, and that cancels out, giving us 4 plus square root of x plus 16. And then, of course, since we committed to putting the radical over here, instead of leaving it there, I moved it over so it wouldn't be negative anymore. But that means I need to get rid of the 4. So you're left with x minus 4 is equal to radical x plus 16. Now, that's how I approach it. Now, I approach it sort of mentally in one step. I say, oh, that's negative. I'm going to put it over here so it'll be positive. And at the same time, I'm going to minus the 4 over here. So however you get there, you should get this or you should get this. It doesn't matter which side the radical's on, but it is a positive x, a negative 4, and a positive radical, whichever side it's on. Okay? So whatever strategy you use to get there, this is where you need to get, either one of these. These have the same value, but that's just something to be really cautious about when you are isolating to make sure if you're moving a radical, make sure that the radical ends up alone and positive.
Well, if you're moving that x from the left side to the right side, wouldn't it be negative?
This x right here?
Yeah.
Well, we left